that was a good demo of how agentic AI or multiple AI agents can actually come together to solve a real world problem, right? And for the techies out here, since I'm a techie, I wanted to actually talk about the architecture of how something like this was built. This is not meant to be a product, but a showcase of the power of agentic AI. These are actually available for you to play around, and I'm happy to help you get started with this. At the bottom of everything is a data layer, right? We need a large volume of data to train models, to consume data, as well as patient records that have to be processed. Then we have the agentic layer, which, as you heard in the video, we have something called as an agentic orchestrator, which is like the scheduler in the operating system. It knows how to invoke the right kind of agents. And if you're unfamiliar with the term AI agents, AI agent is just another application that relies on the power of AI and large language models like ChatGPT, as an example, to essentially understand the scope of the problem that it's been delegated to do, reason with the data that's available to it, take decisions, and actually implement those decisions. That's what an AI agent does. So in this particular example, you can see several agents that are meant to be helpers for doctors performing very specialized tasks. Each of these agents can either be backed by essentially a generic, we call them foundational models like ChatGPT or like Llama or like Gemini, or use very domain-specific models. So for example, if you look at the space of proteins, AlphaFold that DeepMind released, and there are several other models like that that actually perform very, very specific functions. Now, the agent orchestrator is the layer that by itself is an agent, defines the workflow or the sequence of how you want to execute or how to invoke the right agent to perform the right task at the right time. So this is how a typical agentic AI system would be designed. And at the end of the day, we do not want special applications to be created that we have to build special applications to train doctors and do things on. The best way is to integrate these agents into the tools and software that you use on a day-to-day basis, right? So in that sense, we've done quite a bit of work trying to integrate these into Microsoft Teams. So if you're using Teams for communications among doctors, just think of an agent just popping up in that chat, being able to interact with you in real time in natural language. And if you're writing a report or making a presentation for the tumor board, it's integrated right into the Microsoft Office suite of products. So just an example of how the power of AI can be, and agentic AI can be applied in the field of medicine, right? I am going to now move on through, I'm going to click through a couple of examples in the interest of time and move to one last example of an area that's very, very promising from my perspective. It's an adjacent area to healthcare, right? So basically, we want to, AI, we've heard of the term personalized care, predictive healthcare. Those are all standard, parts of it. And today there are lots of services that are out there. And one such example was a bot that was developed basically to help, patients who are either, COVID, showing symptoms for COVID-19. So this was done at scale, and I think CDC numbers were staggering. In the interest of time, I'm skipping through the implementation details, and I'm happy to share them with you offline. But they showed that a significant number of people actually used this, and it had real-world benefits to help patients, right? Again, beyond just healthcare and direct, help for doctors, insurance management, claims management is an extremely painful area for patients when they visit doctors, specifically in the US. And it's specifically around documents going back and forth. And AI has significant potential in essentially helping there. And you've heard during the panel discussion before, preventive healthcare is a very big area, and AI has significant potential in solving that problem as well, right? Last but not least, I wanted to talk about an area that's closer to me, which is essentially AI. If I look at AI, the most impactful space would be in transformation in scientific discovery. And it's a shameless plug. That's a product that I worked on that I signed up to run. And we've recently announced this product called Microsoft Discovery. The intent is to enable scientists, specifically pharma companies in this context, who could essentially use the power of AI to take the time. It's really powerful in the sense that we are combining the power of AI with supercomputing and down the road quantum computing to essentially reduce the time it takes to make drugs and essentially improve the efficiency right through the process. So we want to automate and help validation of as many things as possible and essentially use the power of AI and supercomputing to deliver benefits. What used to take a decade could now be done in a couple of years, right? We've demonstrated the capability of this in the material sciences space, but we're actively working in the drug discovery space to essentially assist certain pharmaceutical companies with their drug discovery needs. So there is significant application of AI in this space as well that could benefit the field of healthcare. So I just wanted to say thank you to all of you for being here and for essentially giving me a chance to be part of this session and for meeting such illustrious presenters here. Thank you so much.